What if everything we thought we knew about the birth of our universe was wrong? What if the Big Bang, that singular moment scientists have pointed to for decades as the genesis of everything, was merely one chapter in a much grander cosmic story?
Welcome back to the channel, Cosmic Explorers.
Today, we're diving into one of the most mind-bending questions in all of cosmology. Was the Big Bang really the literal beginning of everything?
Or could something else have existed before the birth of our cosmos?
Prepare yourself for a journey that will challenge everything you think you know about our universe's origins. We'll explore groundbreaking theories from Nobel Prize-winning physicists, examine shocking discoveries from the James Webb Space Telescope, and confront the possibility that our universe may be just one in an infinite cycle of cosmic death and rebirth. If you're ready to have your mind completely blown, stay with me, because what I'm about to reveal could change how you see existence itself. Before we dive into the revolutionary alternatives, let's establish what mainstream science has been telling us for decades. The standard Big Bang theory suggests that roughly 13.8 billion years ago, all matter, energy, space, and even time itself erupted from an infinitely dense, infinitely hot singularity.
In less than a second, the universe expanded from smaller than an atom to astronomical proportions, a process called cosmic inflation.
According to this model, there was no before the Big Bang because time itself began at that moment. As the legendary physicist Stephen Hawking famously said, the question of what was before the Big Bang is just as pointless as asking which direction is further north than the North Pole. Hawking's point was elegant in its simplicity: since time began with the Big Bang, asking what came before it is meaningless. The laws of nature themselves suggest that the universe could emerge without requiring energy or a cause.
It's a neat and tidy explanation that has dominated cosmology for generations. But here's where things get interesting.
Despite its widespread acceptance, the standard Big Bang theory leaves several profound questions unanswered, questions that have troubled some of the greatest scientific minds of our time.
First, there's the fundamental mystery at origin: how does something emerge from nothing?
What mechanism could possibly trigger the sudden appearance of all matter and energy in the universe from absolute nothingness?
Was it random chance? A physical law we don't yet understand?
Or something else entirely?
Then there's the puzzle of uniform distribution.
When astronomers look at the cosmos on a grand scale, they notice something peculiar: matter and radiation are distributed with remarkable evenness throughout the observable universe. Galaxies, gas nebulae, and cosmic background radiation show similar densities and patterns regardless of which direction we look. This uniformity presents a serious problem for the Big Bang theory. Without some additional mechanism, there simply wasn't enough time after the Big Bang for these regions to communicate with each other and achieve such perfect equilibrium. Scientists proposed cosmic inflation to solve this, a brief period of exponential expansion faster than the speed of light, occurring just after the Big Bang.
During this phase, the primordial universe supposedly expanded by a mind-boggling factor of 10 to the power of 30 to 10 to the power of 1000 within mere fractions of a second. But what if there's a simpler explanation? What if our entire picture of cosmic development is fundamentally flawed?
Enter the James Webb Space Telescope, humanity's most powerful eye on the cosmos and a marvel of modern engineering that has been systematically shattering our assumptions about the early universe. Since its deployment, Webb has made several discoveries that have left cosmologists scrambling to explain phenomena that simply shouldn't exist according to our standard model. Perhaps most shocking are the so-called universe breakers, massive galaxies observed in the very early cosmos, dating back more than 13 billion years. According to our models, these galaxies shouldn't be there. They're fully formed, as massive as our Milky Way, and exist at a time when the universe was supposedly too young to have accumulated enough matter for such structures.
But that's not all.
Webb has also detected supermassive black holes in the early universe that defy explanation. These cosmic monsters, with masses millions or billions of times that of our Sun, appear far too early in cosmic history to have formed through any process our current models can explain. And if that weren't enough to keep cosmologists awake at night, Webb has also confirmed measurements suggesting that the universe is expanding faster than our theories predict, a phenomenon known as the Hubble tension. When multiple independent lines of evidence all point to the same conclusion, that something is fundamentally wrong with our understanding of cosmic history, it's time to seriously consider alternative explanations.
And that's where things get truly mind-blowing. What if the Big Bang wasn't the beginning at all?
What if it was merely a transition, a cosmic reset in an eternal cycle of destruction and rebirth? This idea, while revolutionary to modern ears, is actually ancient in its inspiration. Many early civilizations conceived of time as cyclical rather than linear. Now, cutting-edge physics is bringing us back to a similar conception on a universal scale. Several competing theories now suggest that our universe emerged from the remains of a previous cosmic era. In this framework, the Big Bang wasn't so much a bang as it was a bounce, the moment when a previous contracting universe reached its minimum size before expanding outward again.
This approach elegantly solves several problems with the standard model. 1.
The causality problem disappears. If matter has always existed in an eternal cycle, we no longer need to explain how something emerged from absolute nothingness.
2.
The uniformity puzzle is resolved.
The remarkable evenness of matter distribution makes perfect sense if it was all compressed together at the end of a previous cosmic cycle, thoroughly mixed, and then expanded outward again.
Kindly like, share and subscribe our channel for further more updates about space.